Alright, so this is lesson 43, solving rational equations. The goal for today, students will solve rational equations. The word rational, whenever you see the word rational in math, it means that it's a number that is you could write as a fraction. So as long as you can write a number as a fraction, it's rational. Okay, some numbers are rational, some are irrational. You should know that already. And since we're dealing with fractions, remember what happens if our denominator is 0? What's that called? Turn to your neighbor and help them remember. What is a denominator that's 0 equal to? What does it make the number? What do you think? Someone? I heard it. It starts with undefined. Good. It's undefined, right? We don't like, in math, we don't like it when numbers are divided by 0. So we call that undefined, okay? That's stuff you should know already, okay? And we're going to talk about, we're going to be using the concept you learned from 7th grade proportions, okay? So this is stuff you should know already. These are the skills. We're just working with harder problems today, okay? So here are the steps. If you're in the video, please pause here and write these down. Okay, numbers 1 and 2, just watch. Pencils down. Pencils down. Okay, just watch right now. So number 1, it says k minus 8 over 2k squared minus 1 over k squared is equal to 1 over 2k squared. The directions here should say solve. Okay, so I need to figure out what is k equal to here. So I'm noticing that I have fractions and I have variables in the fraction. So I need to automatically think, are there any excluded values? You should know what excluded values are already. So this first denominator is 2k squared. I need to make sure that I identify any excluded values. So I'm going to take 2k squared and just write it to the side and solve to see if there are any excluded values. When I do that, I see k cannot equal to 0. Right? Remember that from last year? Right? Okay. What was that? Okay. So k can't equal to 0. The next thing I want to do is I want to make sure that I have a fraction equal to another fraction. I have a fraction by itself on the right side, but the left side I have two fractions with different denominators. So since they are different denominators, okay, I need to find a common denominator. This has 2k squared, this has k squared. So this has k squared, this side has k squared, this side has a 2. This fraction it doesn't have a 2, it has a 1 there. So I'm going to have to multiply it by 2. Okay, so when I do that, I'm going to multiply it, I'll bring down k minus 8. Or actually, I'm going to bring down my new common denominator, 2k squared. Then I'm going to bring down k minus 8. And then I have negative 1 times 2 is negative 2. And then I'll bring down the rest of the problem. So I got 1 over 2k squared, okay? And I want to simplify this. K minus 8 minus 2 is going to be k minus 10 all over 2k squared, which is equal to 1 over 2k squared, okay? Next thing I want to do, now that I know that I have a fraction equal to a fraction, I want to cross multiply. So I'm going to multiply this whole first numerator times this whole denominator here. We got k minus 10, which has its own imaginary parentheses. We're going to multiply k times 2k squared is going to be 2k cubed. We got negative 10 times 2k squared is negative 20k squared, which is equal to 2k squared times 1, which is going to be equal to 2k squared. Okay? Now this is just a problem where we have to solve by factoring. So I'm going to combine like terms. I'm going to put my k squareds together, subtract 2k squared on both sides. When I do that, I get 2k cubed minus 22k squared is all equal to 0. Now that the left side is isolated from the 0, I can factor out something. I know that 2 goes into each of these, and k squared goes into each of these. I'm going to factor out 2k squared from these two. So we got 2k squared times k minus 11 is equal to 0. I'm going to use the zero product property. I'm going to say 2k squared is equal to 0 and k minus 11 is equal to 0. So divide both sides by 2. So k squared is equal to 0, therefore k is equal to 0. And then the second one, I got k minus 11. Add 11 to both sides. You got k is equal to 11. Okay. Now I'm almost done. I need to check for extraneous solutions. Remember at the beginning, what was my one excluded solution? 0. Notice how 0 is one of my solutions here. Can 0 be a solution? No. What happens? It'll make it undefined. So this is, even though this is a solution, it's called an extraneous solution. It's not really a solution because we can't have k equal to 0, because if we do, it would be make the problem undefined. So we want to make sure that we cross out k is equal to 0. This is an extraneous solution. So the only solution here is k is equal to 11. Okay? That's number 1. All right? So what did I just do here? First thing I did is I identified any excluded values. I took the denominators to the side, figured out k cannot equal to 0. K squared over here cannot equal to 0, therefore k can't equal to 0. So there's only one excluded value. Second thing I did is I made make each side of the equation over one common denominator. So this left side had 2 different denominators, so I multiplied this by 2. Made this left side a common denominator of 2k squared, and this right side already had its own denominator. Then I simplified. I had k minus 10 over 2k squared is equal to 1 over 2k squared. Third thing I did is I cross-multiplied. When I did that, I had this equation here, 2k cubed minus 20k squared is equal to 2k squared. Combined like terms, we got this. And then I factored and solved the number 5. And then I figured out I have 2 answers, k is equal to 0 and k is equal to 11. And then the last step, check for extraneous solutions. I know k can't equal to 0 because it's an excluded value. Even though it says it should be an answer, it's not. So it's an extraneous solution. Okay, so that's number 1. Okay. Number 2, I'll do the same thing. First thing I want to do is identify any excluded values. We got 5r is a denominator here, and we have r here as a denominator. So I'm going to move 5r to the side, and I'm going to figure out what the excluded values are. So we got r cannot equal to 0. So that's the first thing. And I have another r here. If I were to put r is equal to 0, you'd still get the same excluded value. R cannot equal to 0. Okay? Next thing I want to do, I'm noticing that this left side of the equation does not have a common denominator. This has a denominator of 5r. This one has a denominator of 1. So I need to multiply the second denominator by 5r and the numerator by 5r, so I have a common denominator of 5r. So we got 6r plus 1 times 5r is 6r. And we got minus 7, bring that down. New denominator of 5r is equal to r plus 6 all over r. Okay? Next thing I'm going to do, I'm going to cross multiply since I have the same, or I have one fraction equal to another fraction. So it's like a proportion problem. We got 6r minus 7 times r is going to be 6r squared minus 7r. And then we got 5r times r plus 6 is going to be 5r squared plus 30r. Okay? Then we need to combine like terms. I'm going to subtract 5r squared up from both sides and negative 30r from both sides. So we're going to get 6r squared minus 5r squared is going to be r squared. Negative 7r minus 30r is negative 37r is equal to 0. And then I'm going to factor out an r here. And I'm going to use the zero product property. R is equal to 0. And over here I get r minus 37 is equal to 0, making it a solution of r is equal to 37. At this point, students say that the problem's done. Are we done yet? No, we have to check for extraneous solutions. We know that the original problem said r cannot equal to 0 because it would make it undefined, right? And I'm noticing one of my solutions is r cannot equal to 0. So therefore, what's my extraneous solution? R cannot equal to 0. So we cross that out with an x like that. Okay, you have to cross it out. All right, so the only solution is r is equal to 37. All right? So that's all we're doing today. Any questions on numbers 1 or 2 on any of the steps? Okay, cool. So get to know your new neighbor or your old neighbor. 1's till the 2's about number 1. And then 2's till the 1's about number 2. Here we go, number 3. Let's do this one together, number 3. So write down number 3 for me, please, on your whiteboards. And give yourself some space to work. So we're going to solve for n here. Okay, so step 1, find any excluded values. Identify any excluded values with your neighbor. What could be an excluded value? Okay, what's our excluded value, everyone? 0, right? Okay, so in case you didn't get it, just needed to put 5n or n squared or 5n squared into the side, you'd still get the same answer, and it cannot equal to 0. Okay, now, the left side, do we have a common, or I'm sorry, on the left-hand side, do we have one fraction on the left-hand side of the equal sign? Yes or no?
Yeah.
We have two fractions. We only want one fraction, right? So do we have a common denominator? No. What's our common denominator I could have between 5n and n squared? 5n squared, good. So what should I multiply 5n by? N, good. What should I multiply n squared by? Good. So let's do that. Let's write those in. Okay. So now our numerator, our first one is going to be n times 1 is going to be n. And then we got negative 1 times 5. What's negative 1 times 5? Negative 5. Okay? New common denominator 5n squared is equal to 3 over 5n squared. Okay? Okay, so do we have a fraction equal to a fraction now? Yeah, we do. So now we could cross multiply. Okay? So we know that this has parentheses around it, and minus 5 does. So we're going to cross multiply it with the second denominator. We got n minus 5 times 5n squared is going to be 5n cubed minus 25n. Okay. Then we got to cross multiply 5n squared times 3 is going to be 15n squared. Okay. Then we want to combine like terms. I'm going to subtract 15n squared on both sides. We're all doing this together, so. Negative 25 minus 15 is negative 40n squared. Okay, turn to your neighbor. Tell him what you could factor out of this binomial here. Okay, what can I factor out, everyone? Good, 5n squared. So we got 5n squared times n minus 8. Okay? So I want you to finish up my prompt for me now. Okay? Okay, so on this one you should have the following. Two answers, n is equal to 0, n is equal to 8, but can n equal to 0 here? Yes or no? No, it can't, right? So we say that's an extraneous solution. N is equal to 8 is the only solution, okay? Here we go, number 4. Okay, erase your boards, number 4. I'll start this one off, and then you'll finish it up. Write this down, please. Okay, so we got 1 over 2n squared minus n plus 3 over 4n squared is equal to 1 over 4n squared. Okay? So, turn it over, tell them, do we have a fraction equal to a fraction? Yes or no? No, we don't. We have two fractions equal to a fraction, right? So, what's the common denominator I could have of the first fraction? Or the first set of fractions? You see how there's two fractions equal to another fraction? Okay, what's the common denominator here? 4n squared, good. So what should I multiply the first term by? 2, okay? So I'll start you off here. You should multiply the first one by 2. Oh, and we forgot to do excluded values. What's our excluded value here? 0, good. Okay. So we're going to multiply the first one by 2. Okay, so we have 2. And then be careful here, right? We have this negative sign here. What's negative? Look up here. What's negative times n? Negative n. What's negative times 3? Negative 3, good. You have to be careful there because you end up getting, might put the wrong sign and then your problem's wrong automatically. Okay? No bueno, that's right. Okay, and while we're at it, I'm going to combine like terms. I'm going to combine 2 and minus 3, which is negative 1. I'll bring the rest of the problem down. Okay? I want you to finish up the problem for me now. Okay? Ready, set. The answer is, the only answer that is there is n is equal to negative 2. The other one, 0, is extraneous. It's negative 2. Why is it negative 2? Look at the steps here. And some of you put positive 2 as your answer. That's wrong. here or explain why you made a mistake there. Okay, so let me put positive 2. If you made a mistake, please explain it to your neighbor. Ready, set, go. Number 5. Okay, this one's all the way through by yourself.